So today I will be discussing section 8.4, and that's finding sums of infinite geometric series. So our first problem is consider the infinite geometric series 1 over 5 plus 1 over 10 plus 1 over 20 plus 1 over 40 plus 1 over 80 plus the function continues. Find and graph the partial sums Sn for n equals 1, 2, 3, 4, and 5. Then describe what happens to Sn as n increases. So this requires a few steps. Our first one would be to find the partial sums. So our partial sum for S of 1 is just 1 over 5, which in decimals would be 0.2. For our S2, we add that 1 over 10 to give us 0.3. We just continue this adding on the other number till we get S over 3, which is 0.35, S over 4, which is 0.375, and S over 5, which is 0.3875. So we just add one more fraction, or the next number in our infinite geometric series, until we have S5. So our second step then is to plot these points, and we would have our x be the n and our y be the a of n. So we have our S1, which is 0.2, so that would have our x be 1 and our y be 0.2. We continue this all the way through S5 to get our graph here, which is goes up to 0.5 on our y-axis and 6 on our x-axis. And we see that with plotting our points, that our points approach 0.4. So we would write this answer as n increases, S of n approaches 0.4. So that is the solution for this problem. So for our next problem, we would want to find the sum of each infinite geometric series. So this problem has 3 different parts and 3 different equations we need to solve. So here's our problem A. We start off by finding our A1 and our R. So our A1 is 4 and our R would be 0.2. And then to find our S infinity of this, we would have our A1 over 1 minus R, which would give us 4 over 1 minus 0.2. This would simplify to 4 over 0.8 once we do the subtraction in our denominator. So this gives us the answer of S of infinity equals 5 once we simplify that fraction, and that would be our answer for number A. Now for B, we have a little bit of a different problem, but it's still solved the same. So our A of 1 is equal to negative 6. But our R, we would do A2 over A1. So that would give us negative 4 over negative 6, which simplifies to 2 over 3. Then we would plug this in the same way as we would with our previous equation to get S of infinity equals negative 6 over 1 minus 2 over 3. And this would also simplify to negative 6 over 1 over 3. And we would solve that to get our answer of S of infinity equals negative 18. Our third problem we have here, we would solve the same as B. So our A1 would be 2, our R would be 5 over 2. And since R equals 5 over 2, and 5 over 2 is greater than 1, there's no sum because the R is greater than 1. So that automatically means there will be no sum to the equation. So next we have a word problem. So a pendulum that is released to swing freely travels 100 centimeters on the first swing. On each successive swing, the pendulum travels 96% of the distance of the previous swing. What is the total distance the pendulum swings? So here is a diagram of what our pendulum looks like. So for one swing we have 100 centimeters. Then our next swing we would have 96% of that 100 centimeters. Then our next one we would have 96% of this one, and then that pattern would continue on. So our distance traveled can be given by the infinite geometric series of 100 plus 100 times 0.96 plus 100 times 0.96 squared, and this would continue on until the pendulum would stop swinging. So in this equation, our A1 would be 100, and to find our R, we would do A2 over A1, which would give us 100 times 0.96 over 100, which would just simplify to 0.96 as the hundreds cancel out. So we plug that into our S infinity problem to get 100 over 1 minus 0.96, which would give us 100 over 0.04, and that would simplify to 2500. So the pendulum travels a total distance of 2500 centimeters, and that is the answer to this problem. So our last example is to write the fraction 0.777 as it continues on as a fraction in its simplest form. So 0.777 equals 0.7 plus 0.07 plus 0.007, as those zeros are placeholders, and this equation continues on. So our A1 would be 0.7, and our R would be A2 over A1, which would be 0.07 over 0.7, and that would simplify to 0.1 when we do the division. So we put this in our equation for S infinity. It would do A1 over 1 minus R, which would give us 0.7 over 1 minus 0.1, and that would simplify to 0.7 over 0.9. And if we times this by 10, we will get 7 over 9, and that is the most simple fraction that we can get. So that is the decimal 0.777 as a fraction in its simplest form. So thank you for watching section 8.4. That is it.